So this is tempering chocolate. What is it? How and why do we do it? And why does it work? So what is tempering? Tempering is a process that stabilizes all the fats in chocolate to prevent the chocolate from blooming. So chocolate's made of a bunch of different fats and then some things that actually provide the taste. And if the chocolate isn't all solidified, the fats will float up to the top. And you've seen fat before in like bacon, and it'll get this white coating on top, and you don't want that. So how do we temper chocolate? To do this, first all the fats have to melt, and this happens at 104 degrees Fahrenheit. But if the chocolate goes above 110 degrees Fahrenheit, the chocolate may enter an undesirable crystal structure. And in this crystal structure, it doesn't necessarily bloom, but it might just not have the right texture, or it might be too easy to melt or something like that. So to keep the tempered crystal form, the chocolate has to be cooled to 80 degrees Fahrenheit to allow the fats to stabilize. And finally, the chocolate can be heated back up to 89 degrees Fahrenheit for dipping while retaining the desired crystal form. And this is a bunch of numbers that are really complicated, which is why I have, you can see that over there, that's a temper. It's a machine that basically measures the temperature of the chocolate, so it controls it and brings it to all these numbers here. And you can do this manually by having a double boiler and sitting there with the thermometer and measuring the temperature, but that takes a long time. This is a model of a chocolate temper, and you can see here this part is like this part in the real chocolate temper. And they both have their little scraper bits. And these scraper bits prevent the chocolate, once it's melted, from going back in to where I'm going to originally place the chocolate. So this is the chocolate that we start out with, that we want to temper. And really there's a lot more than this, because this here keeps the chocolate from falling out of the bowl. So the chocolate will be piled up high. So imagine like 100 of these maybe. And they all go in here, put them in, and then it gets warm, and when it's warm, they melt, and they come along to the other side, and you see this scraper here is preventing them from going back to the first side. So then once the chocolate's all melted, and it's lost its crystal form, the chocolate temper will beep and say, I need a chocolate crystal. And then you'll put this in. And you either press 1 if you're certain that this is connected correctly and you know this is the best type of chocolate, or you can press 2 if you're kind of worried that something might be in the wrong place and it should also be more precise with the temperatures. So you put in your seed chocolate, comes over here, and then since there are electrons in all of these clusters of molecules, the different clusters of molecules are attracted to each other. And now since they have a pattern, they want to form the same pattern as the seed chocolate. And they go over here and they all bind together. Now really, if you think about when you dip chocolate, it really isn't a hard thing, because this would never stick to a strawberry. Really, if you think about it and you have a box of pencils and you shake it gently, all the pencils are going to line up in the same way. And they're going to stay that way unless you like start shaking it really hard or dip something in there. So that's really, this is actually a liquid crystal, not a solid crystal. And once it has a crystalline form, when you dip something in there, it'll stick and it'll have the right form, and there won't be any evil bumps or white spots or anything. And that's how a chocolate temperer works. As a counterexample, if your chocolate solidifies at 79 degrees Fahrenheit, your chocolate will be hard to break and will melt very easily. Or if the chocolate solidifies at 97 degrees Fahrenheit, it can take weeks to actually have its crystal structure form. So we're trying to get it at this specific crystal structure. Okay, what is crystal structure? Like water, chocolate has a melting point and a freezing point, and when frozen it forms crystals. The chocolate molecule is more complex than the water molecule, and it forms 6 different types of crystals because it has 6 different freezing and melting points. And what we're trying to get with what we like and what we consider to be tempered chocolate is type 5. And tempered chocolate is what's known as type 5. So here you have this, and this is actually a very recent thing, and it's, if you go down to the molecule level of chocolate, it's what it looks like. Okay, so this is kind of hard to interpret, but this is a side view, so it looks vaguely like this. If you didn't have 3D, that would be what it would look like. So each of these orange things is one chocolate. I can't really say it's a molecule because it's composed of different fat molecules, but it has like 4 different types of fats and a lot of other stuff that you find in chocolate. So you can see it's much more complex than the water molecule. Okay, so then what does the chocolate molecule look like? Really, they don't have a picture, because as you saw in the last slide, that was about as in-depth as they've gone so far, and even then you can't see all these things. But it has all these sorts of things inside chocolate and then some.